Here's an example of a rate problem. This many liters of hydrogen is collected in 3 minutes, and we're asked to calculate the rate in milliliters of hydrogen per second. Rate is amount over time, so we can say rate is the volume of H2 over unit time. The volume of H2 is 0.0036 liters, but we are asked for the volume in milliliters of hydrogen, so we must change the liters to milliliters. So we put in the unit milliliters over liters. And we know that there's 1,000 milliliters in 1 liter. Now we need to put the time unit on the bottom. Notice the time is 3 minutes. So we put in 3 minutes here. Looking at our rate, we need the rate in mils of hydrogen per second. So we have to change the minutes to seconds. So we put in the unit seconds over minute so that minutes will cancel out. And as we know, 1 minute is exactly 60 seconds. So we can cancel out the liters and we can cancel out the minutes. Before we figure out the final answer, let's put some brackets around these. And working these out with a calculator, the top would come to 0.0036 times 1,000, which is 3.6 milliliters. And the bottom works out to 3 times 60, which is 180 seconds. Dividing the top by the bottom gives us our final answer of 0.020 milliliters of hydrogen per second. Notice our significant digits. There are 2 here and 2 here. Our final answer, therefore, has 2 significant digits, this 2 and this 0. In this problem, we're given the rate of hydrogen production is 0.02 milliliters of hydrogen per second. We're asked to calculate the volume of hydrogen produced in 5.5 minutes. Rate is amount over time, so we can say that rate is volume of H2 over unit time. In this problem, we're asked to find the volume, so we can rearrange this equation by cross-multiplying. So volume of H2 is equal to rate times unit time. The rate's 0.02 milliliters of hydrogen per second, and we times that by the time, which is 5.5 minutes. But you can see, in order to make our units work out, we have to change minutes into seconds. So we multiply by seconds over minutes. And as you know, 1 minute is 60 seconds. Now we can cancel out the seconds and the minutes, and the unit we'll be left with is milliliters of hydrogen, which is what we want. So now we calculate the final answer. 0.02 times 5.5 times 60 equals 6.6 milliliters of hydrogen. Again, we have 2 significant digits here and here, so our final answer has 2 significant digits. In this problem, we're given the rate of the reaction, and we're asked to find out how long it will take to produce 3.8 liters of hydrogen. First of all, the equation for rate is volume of H2 over time. If we cross-multiply, we get rate times time is equal to volume. In this problem, we want to find the time, so we divide both sides by rate. And we get this equation here. The volume of H2 is 3.8 liters, and the rate's 0.02 milliliters per second. So we put those in. But notice liters is on the top, milliliters is on the bottom. So we have to change liters to milliliters. So we multiply by 1,000 milliliters per liter. We can cancel out the liters, and we can cancel out the milliliters of H2 here and here. Now we're left with this. Seconds is on the bottom of the bottom. That means it's actually a unit on the top. So that many seconds. Multiplying and dividing that brings us to 190,000 seconds. If we want a more convenient time unit, we can change seconds to minutes by multiplying by minutes over seconds. 1 minute over 60 seconds. That's still going to be a fairly large number, so let's change minutes to hours. So we multiply by hours over minutes. Now we can put 1 hour over 60 minutes. We can cancel out the seconds, cancel out the minutes, Do the calculation, and we get 53 hours.